Hello again. We are finishing up our discussion of exponents and exponential functions by talking about recursive sequences and what those are. Okay, they're sequences that begin with A1, and A1 is just a notation that I'm using to symbolize the first term of the sequence. All the terms will be named A something. A1 is going to be the first term. A2 is going to be the second term. A3 is going to be the third term, and so on. All right, so each term, though, is going to be defined by doing something to the term that comes before it. Okay, and there's a notation for that. And then I have to give you the first term as a number. Okay, so let's look at an example. If I have an equals an minus 1 plus 5, well, that seems kind of confusing, but I know that an is a term in the sequence, and an minus 1 would be the term that comes before it. So every term in the sequence is going to be whatever the term before it is plus 5. Okay, so to get from one term to the next, I'm going to add 5. And like I said, I have to give you a first term somewhere to start. So I'm telling you that a1 equals 4. So the first term is 4, and then what this phrase means is that each term is 5 more than the previous term. Okay, that's how you would translate that into English. So if the first term is 4, then the second term is going to be 5 more than that, which is 9. The third term is going to be 5 more than that, so 14. So the sequence goes 4, 9, 14, 19, 24, and so on. You just keep adding 5 starting from 4. All right, here's another example. an equals 2an minus 1, and a1 equals 7. Well, that first phrase means that every term is going to be 2 times the term that came before it. So the previous term. a1 equals 7 just means that the first term is 7. So I'm basically going to start at 7 and keep multiplying by 2 to get from term to term to term. Okay, so the second term is going to be the first term, 7, times 2, which is 14. And if I multiply 14 by 2, I'll get the third term, which is 28. And the sequence keeps going to 7, 14, 28, 56, 112, and so on. Okay? So how do we write these recursive sequences? Well, you need to know what the first term is and how you get from each term to the next term, how each term changes to get the next term. So for example, if I have 3, 5, 7, 9, and 11, okay, the first term is 3. That's the easy thing to figure out. But how do I get from 3 to 5, and 5 to 7, and 7 to 9, and 9 to 11? Well, it looks like I keep adding 2. So the first term is 3. I write that as a1 equals 3. The next part is that an, each term, is going to be the term before it, an minus 1, plus 2, and that's how I write it. Okay, here's another example. 168, 84, 42, 21. Well, the first term is 168. That's easy to figure out. But how do I get from 168 to 84? How do I get from 84 to 42? How do I get from 42 to 21? Well, I can't add the same thing over and over again or subtract. But what I can do is I can take half of each term to get to the next one. So I'm multiplying by a half or dividing by 2. So a1 is 168 and an is half of an minus 1. Each term is half of the term that came before it. So that is the end of exponential functions and exponents, and that is the end of this lesson on recursive functions. So if you have any questions, please let me know, and I will see you tomorrow.